What if I told you that in the world of computers, 8 could sometimes feel a whole lot like 16? It's one of the most confusing, most debated claims out there, that an 8GB Mac is somehow the same as a 16GB Windows PC. Now, this isn't just some random argument for tech nerds online. It actually creates a huge problem for anyone, maybe even you, trying to buy a new laptop. Are you getting tricked into paying a premium for a brand name, or is there some kind of secret magic happening inside Apple's machines? Well, today, we're going to find out the real answer. We are putting this myth on trial with a head-to-head stress test to see once and for all what the truth really is. So let's just stare at this claim for a second. This one sentence. This is the cause of so many arguments. It's built on a pretty wild idea, right? That a MacBook with 8GB of memory can perform just as well as a Windows laptop with double that amount, 16GB. Now, when we say memory, what we're really talking about is something called RAM. Just think of RAM as your computer's short-term memory. It's where it holds all the apps and all the tasks you're currently working on, like right now. It's kind of like the computer's consciousness. So this claim suggests that a Mac can handle just as many things at once with half the brain power. It's basically saying that the numbers on the box don't tell the whole story. It's a bold statement, and let's be honest, it sounds a little too good to be true, doesn't it? So is there any real truth to this, or is it just a clever marketing line designed to make you feel okay about spending more money? That is the one question we are here to answer today. We're going to completely ignore the marketing hype, we're going to ignore brand loyalty and all those online flame wars. Instead, we're going to focus on cold, hard evidence. And what does that mean? It means we're going to push these computers to their absolute limits and just watch what happens. We'll measure their performance, not with a bunch of confusing technical jargon, but with real-world tasks that you might actually do every single day. By the end of this, you'll know exactly what's going on inside these machines and whether this famous claim is fact or just fiction. Okay, before we can even dream of starting our tests, we need to be crystal clear about one thing. The physical hardware, that little memory chip itself, is exactly the same. A gigabyte of RAM is a gigabyte of RAM whether it's sitting inside a Mac or a Windows PC. There is no secret magical Apple RAM that is physically twice as powerful. So if the hardware isn't different, where on earth could this supposed advantage be coming from? Well, the answer is in the software, specifically the operating system. That's the main program, like macOS or Windows, that controls everything the computer does. Let's use an analogy to make this really, really simple. Imagine you have two chefs, each in their own kitchen. Both kitchens have the exact same amount of counter space to work on. That counter space, that's your computer's RAM. And the chef is the operating system. Now, one chef is an absolute master of organization. They clean up as they go, they place their ingredients perfectly, and they can somehow prepare this huge, complex meal on that small counter without ever running out of room. The other chef, though, is, a bit messy. They leave stuff out, they're not as efficient, and they quickly run out of space just trying to make a sandwich. They end up piling things on the floor just to keep working. In the end, the counter space was exactly the same, but the result, what they were able to cook, was completely different. See, the difference wasn't the kitchen, it was the skill of the chef. And in the same way, the difference between these computers isn't the RAM itself, but how the operating system uses it. Okay, so to find out which chef, which operating system, is better at managing its kitchen, we've designed a pretty brutal real-world stress test. We're not going to use those abstract benchmark tests that you see online that just spit out a single number. A high score is nice, but it doesn't tell you how the computer will actually feel when you're in the middle of a project. For example, a sports car might have a super high top speed. That's its benchmark score. But that tells you nothing about how it'll handle being stuck in rush hour traffic. That's the real-world test. We want to simulate the real, messy, and demanding way people actually use their computers. Think about a busy student during finals week, or a creative professional on a tight deadline with a million things open at once. That's the kind of chaos we want to create. We're going to push these machines to their absolute breaking point to see which one can handle the pressure without freezing up and crashing.
Let's meet our 3 contenders for this challenge. First up, we have a standard Windows laptop with 8GB of RAM. You can think of this one as our baseline. It's one a lot of people might buy for everyday use. It's our control group, really. Next, we have another Windows laptop, but this one's got 16GB of RAM. This is our gold standard. This is the powerful machine that the 8GB Mac is supposedly equal to. It's the goalpost we're aiming for. And finally, our third contender, the 8GB MacBook. This is the machine at the very heart of the myth, our challenger. By testing all 3 side by side, we can make a perfectly fair comparison. We can directly compare the 8GB Mac to the 8GB Windows PC to see which one performs better with the same amount of RAM. And we can also see if the 8GB Mac can actually keep up with the 16GB Windows PC. This setup is designed to give us a clear, undeniable answer.
We call this test the Gauntlet, and it's basically designed to be a total nightmare for these computers. Each step adds more and more pressure on the system's short-term memory. First, we open over 20 tabs in Google Chrome. We're talking YouTube videos, news sites, all that stuff. Every single one of those tabs is like its own mini application that needs its own little piece of the computer's memory, its RAM. Then, while all those tabs are still open, we launch a whole suite of Office apps. Word, PowerPoint, Excel, messaging apps, the kind of things many of us have running in the background all day. After that, the real test begins. We run a super complex task in an Excel sheet with 30,000 rows of data. This demands a sudden, huge chunk of memory. Then we open a big, complicated Photoshop file with lots of layers, another classic memory hog. And for the final knockout punch, we ask the computers to export 100 giant, high-quality photos from Lightroom. Now, the most important part of this whole test is that we never close anything. Everything stays open the entire time. This forces the computer to juggle everything at once, which is the ultimate test of its memory management and, well, the skill of its chef. So we put all 3 of our laptops through this brutal gauntlet, and we watched them very, very closely. We weren't just looking at performance charts or data. We were paying attention to how they felt to use. Was the mouse cursor moving smoothly? Did applications open right away when we clicked on them? Or was everything just slow, laggy, and frustrating? And the results were genuinely shocking. The difference wasn't small or subtle at all. It was a complete night and day experience, and the entire myth just started to crumble during one specific moment in the test. Let's dig into exactly what happened. So the moment of truth arrived when we got to that giant Excel spreadsheet. And remember, at this point, all those 20+ Chrome tabs and all the Office apps are still running in the background, just eating up a big chunk of each computer's short-term memory. So we asked each computer to do one simple thing. Take all 30,000 rows of messy, unorganized data and instantly turn it into a perfectly structured table with just one click. Now, why is this so hard for a computer? Well, because to do this, the computer has to load all 30,000 of those pieces of information into its short-term memory, the RAM, all at the same time and then rearrange them correctly. It's like asking someone to instantly sort a massive, messy pile of 30,000 documents by hand. It puts the system under sudden, extreme pressure, and it's the perfect way to see which computer will crack. And the results were just stunningly clear. On the 8GB Windows laptop, it was a total disaster. The second we clicked the button to format that table, the computer just gave up. We got the spinning blue circle of death, the top of the Excel window turned that hazy gray color and showed those 2 dreaded words, not responding. The program was frozen solid. In fact, the entire computer became unusable. We couldn't switch to another app, we could barely even move the mouse. It just completely choked under the pressure. But what about the 8GB MacBook? With the exact same file, doing the exact same task, it finished the job instantly. 0 delay. No lag, no spinning circle. It just worked like it was the easiest thing in the world. And the whole system stayed perfectly smooth and responsive the entire time. And the problems weren't just in Excel. The 8GB Windows PC struggled through the entire gauntlet. Just switching between programs was slow and jerky. And when we went back to look at our Chrome tabs, we saw something really frustrating. A lot of them had to reload from scratch. What does that actually mean? Well, it means the computer had run out of its short-term memory. So to save space, it had to forget what was on that web page. It's like our messy chef just clearing a dish off the counter before you were finished with it. And when you want that dish back, the chef has to prepare it all over again from the beginning. In the same way, the computer had to re-download the entire page from the internet, which is just slow and incredibly annoying. The whole experience was just painful. So the feeling of using the computers was clear, but this data right here shows us exactly why it all happened. Let's walk through this table nice and slow. First, look at that row called physical RAM used. You can see the 8GB Windows PC was at 99%. It was using every last bit of its short-term memory. The counter was totally full. Now look at the next row, available RAM. This is the key. The Windows PC had only 139 megabytes of memory left to handle anything new. That is practically 0 breathing room. By comparison, the 8GB Mac, doing the exact same work, still had about 850 megabytes free. But the most important number here is in that last row, system status. The Windows PC shows 100% disk use. This is critical. It means the computer had completely run out of its fast, short-term RAM, its countertop space, so it started using its main storage drive as emergency memory. This is like our chef running out of counter space and starting to prep food on the slow, dirty floor. The main storage drive is thousands of times slower than RAM, and relying on it is what caused the entire computer to just grind to a halt. Meanwhile, the Mac was under yellow pressure, meaning it was working hard, but it was managing, and the 16GB PC was just smooth. No issues at all. This chart just makes that difference impossible to ignore. It's a visual of the available RAM, the breathing room that each computer had left. I mean, look at that tiny little red bar for the 8 gig Windows PC. That's its 139 megabytes of free space. It's barely even visible. Now look at the yellow bar for the 8 gig MacBook. It's more than 6 times bigger. It has so much more space available for the next thing you ask it to do. And of course, the 16 gig Windows PC has that huge green bar, representing a massive amount of free space. This picture really does say it all. The Mac and the first Windows PC started with the same amount of RAM, the same size countertop, but the Mac's Chef, its operating system, was so much better at managing its space that it had way more room to work with when things got really busy. So this brings us to the biggest and most important question of all, why? Why did the Mac perform so much better? We already established that the physical hardware, the RAM chip, is the same, so the difference has to be in the software. And it all comes down to how Apple's operating system, macOS, manages its memory. It has a couple of very clever tricks up its sleeve that make a huge difference when the computer is under pressure. To understand these tricks, let's start with one more simple analogy. Okay, imagine your computer's RAM is a workbench in your garage, and your main storage drive, the SSD, is like your big toolbox where all your tools are stored. Every app you want to open, your web browser, your music, a game, is a tool inside that toolbox. To use a tool, you have to take it out and place it on the workbench. Now, if you have a huge workbench, which is like having lots of RAM, you can lay out all your tools and easily and instantly grab whichever one you need. Everything is fast, it's efficient. But if you have a tiny workbench, which is like not having a lot of RAM, it gets crowded really, really fast. If you want to use a new tool from the toolbox, you first have to stop what you're doing, find a tool you're not using, and put it back in the toolbox just to make space. This constant shuffling just slows you down. That's why having more RAM, a bigger workbench, is generally always better. So, what happens when your workbench starts to get full? This is where the Mac's first secret weapon comes in, a trick called memory compression. Let's go back to our workbench analogy. Imagine you have a magical shrink ray. For any tool on the bench you aren't actively using right this second, you can just zap it, and it shrinks down to a tiny size. Your big hammer becomes as small as a pen, your saw becomes the size of a pencil. They're still right there on the workbench, ready to be instantly zapped back to full size the moment you need them, but they take up way less space. That is exactly what memory compression does inside the computer. It finds the data for apps you have open but aren't using, and it squishes it down to a smaller size. In other words, it tidies up the workbench automatically and constantly. And while both Windows and macOS do this, our test clearly shows that macOS is far more aggressive and efficient at it, constantly freeing up space to keep things running smoothly. But what happens if the workbench is totally full, even after you've shrunk all the inactive tools? Then you have no choice but to put a tool away to make room for a new one. This brings us to the second trick, SSD swap. Okay, so imagine you have a storage cabinet right beside your workbench. This cabinet is your computer's main storage drive, or SSD. When the workbench, your RAM, is completely full, the computer takes the tool you haven't touched in the longest time and moves it from the bench into the cabinet. This frees up a spot on the bench for your new tool. Now, the most important part of this trick is the speed of that cabinet. Apple put some of the fastest SSDs in the world in their computers. That means moving tools between the workbench and the cabinet is almost instant. It's so fast you barely even notice it's happening. This is exactly what we saw the Windows PC fail at. Its storage was much slower, so trying to swap a tool to the cabinet was like trying to open a rusty old door that gets stuck. The whole process was so slow that it caused everything to freeze. So let's put it all together. This is the Mac's step-by-step strategy for dealing with pressure. First, it fills the workbench with tools. That's the physical RAM. As the bench starts getting crowded, it seamlessly moves to step 2. It starts shrinking the tools you're not actively using. That's memory compression. If the bench is still completely full and you need another new tool, it automatically goes to step 3. It takes the tool you haven't used in the longest time and quickly and silently puts it in the super fast storage cabinet. That's the SSD swap. This combination of shrinking and swapping is so fast and so efficient that the final result is a computer that stays feeling fast and responsive even when it's under a huge amount of pressure. It's just a smarter, more elegant way to manage a small workspace. All right, so we've seen the test, we've looked at the data, and we now understand the secret tricks the Mac uses to manage its memory so well. It's time to go back to our original question and give the final verdict. Is 8 gigabytes of RAM on a Mac really the same as 16 gigabytes on Windows? Let's bust this myth once and for all. Here is the final verdict, and let's break it down into 4 key points. First, The myth is officially busted. 8 gigabytes is not the same as 16 gigabytes. Our test clearly showed that the 16 gigabyte Windows PC was the overall winner. It handled everything we threw at it without breaking a sweat. A bigger Workbench is still better. Second, and this is the big twist, 8 gigabytes on a Mac is a much, much better experience than 8 gigabytes on a Windows PC. It's not even a close competition. Because of its smart software, its skilled chef, the Mac can handle a workload that makes a similarly equipped Windows PC completely freeze up and become unusable. Third, if you are a serious professional, a video editor, a programmer, an artist, a music producer, you should still get 16 gigabytes of RAM no matter which operating system you choose. For truly heavy work, more physical memory is always going to be better. There's no software trick that can truly replace just having a bigger Workbench to begin with. And the fourth and final point is the most important takeaway of all. The numbers on the spec sheet don't tell the whole story. The amount of RAM you have is only half of it. The other, arguably more important half, is how well your computer's operating system actually uses that RAM. The skill of the chef is just as important as the size of the kitchen. And this ultimately reframes the entire debate, doesn't it? We get so caught up in comparing numbers on a spec sheet, 8 versus 16, this processor versus that one. But what this test really shows is that the user experience, how a computer actually feels to use day to day, is defined by how well the hardware and the software work together in harmony. So the next time you're looking at a new computer, maybe the most important question to ask isn't just about the raw numbers, it's about the intelligence of the system as a whole. It's not just about the size of the Workbench, but the skill of the chef working at it.
If you enjoy this video, please like, share, subscribe and hit the bell to the later update from my channel. Thank you for watching till the end and see you in the next video.